Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Fred Schenkberg. I understand you got a question in, you mentioned the format, I think it was through the article series you do. So a reader of yours sent you over a question.
Yeah, it was interesting. And it's something that I've pondered for some time, and I've written articles about, and it's a really important part of FMEA. So this is a question that relates to how do you prioritize risk? You do all this work in an FMEA to get the functions and the failure modes and the causes and the effects and controls and things like that. And then you can assess how severe the effects are, and you can assess how the likelihood of occurrence of the failure modes and causes and things like that. But then what do you do with that? How do you prioritize? And there's lots of history on this, going back to the 1950s, when the first mill standard came out in that era, actually in the 40s and then 50s. They did it a certain way, and then automotive came online, and they did it a different way. And then a lot of commercial industries came on, they did it a different way. So the question becomes, what's the best way, and how do you represent it? So that's a really good question that a listener asked.
You know, in facilitating FMEAs, that question always comes up, and it's part of it is trust the process, and part of it is, well, let's just say I went into the spectrum of we don't want things that have horrible consequences that happen all the time, and you're not able to interrupt it or stop it. You can't sense it until the current that it happens, and a bunch of bad stuff happens. Everybody nods their head. Yeah, I agree. And then I said, on the other end of the spectrums, there's stuff that even if it fails, nobody will even notice, and it'll almost never happens. And we get plenty of notice that it's about to happen, at which point we're not going to do anything about it anyway. And they all nod and go, yeah, we don't need to do those. And it gets sticky in that, you know, we get 10 things like, we have to fix that. That's a safety issue. We got to fix that. And those are obvious. But it's after that point, it's, well, this one's we don't like that consequence. It's not terrible, yet it occurs quite a bit. So it's kind of the annoyance issue. And then somebody chimes in saying, well, we have a oil light signal on it so that if it really is annoying to you, you could prevent it. And then there's another variation that's very subtle, slightly different levels on each of those three criteria. And then we get 25 or 40 of those. And now we're into this gray, murky area of which one do we work on? And then there's other techniques and sources for that. But I don't emphasize the scoring as much. It's a tool. Engineers like numbers. It's here's one end of the spectrum, here's the other end of the spectrum. Where's this fall? Considering these various factors. And then it always, in my approach to it, it always gets muddy at a point when we're probably not going to address them anyway, because we just don't have enough resources and time after the ones that we know are obvious. And so I don't worry about it all that much, because we're going to work on the ones that are obvious. And it's a good one.
Yeah, that's a really good way to think about it. And you've got the experience to help guide a team into what is obvious and most important. And that's what you're looking for. So you and I have always talked about, and I know Chris says the same thing, that you want to get to the vital few and not the trivial many. And that's every part of FMEA is, you got to keep that as a principle, because I'm not a believer in doing FMEAs on everything. I think we should use the FMEA tool where you have a certain amount of risk present to start with. And so I do not support the idea of some massive big FMEA that includes every possible failure mode on all levels of the system hierarchy. That becomes burdensome, and you end up not spending the human time that you need on the vital few, because you get bogged down with the trivial many. So so when you get to risk prioritization, after you've done the work, let's say you've selected an FMEA, it's important, needs to be done. Then you've got the failure modes, you got the effects, you got the causes, you have the severity of the effects, you have the occurrence of the failure mode / cause. And then you can talk about detection. What's the likelihood that you'll detect the problem before it gets launched, the product gets launched? So you have these risk factors. How do you bring it together? Let's talk about the wrong ways. I don't think the old way of multiplying numbers together to get a single risk priority number is a good way. That's a numbers game. And that, I think I'm aligning with what you're saying there. You don't want to get too bogged down in details.
Well, I've seen it where, I'm in an FMEA and the manager goes, well, that can't be an 8 because we'll have to do something about it. Let's make it a 7. Everybody agree to that? Like,
exactly.
What?
That's a numbers game.
Yeah.
So we don't want a numbers game. RPN has flaws. It was in a lot of the original standards. Now the standards are moving away from it. And the biggest flaw is high severity, low occurrence.
Still needs to be addressed.
Exactly.
Yeah.
And so that is a huge flaw in RPN. And so if people are using RPN, which I don't recommend, but if you're using it, make sure you address your high severities, irrespective of
anything else,
how often they happen.
Yeah, and that's always been a two-tier approach that I've learned and used over the years, is that, you look at the 9 and 10s on a 10-point scale for severity, and as soon as something gets established in that area, I move on. What are the next set of stuff we do? Because we are going to have to do something with that one. There's no more discussion. That's a really bad outcome. If that fails, we have to deal with that. Right, move on. What's next? And we'll come back to it and put action items and stuff on it. But it's fully flushing it out and all the variation cases to that one severity, all the different causes. That's a different project. That's outside FME already now. Let's move on.
Yeah. And another point that I'll make to simplify, because I want to simplify FMEA process, keep it as simple as you can. And another way is to cut down the number of gradations. I no longer think you need a 10-point scale. I think a 5-point is perfectly fine.
Yep. I don't know how many teams you probably ran into it too. You start with a 10-point scale and they go, well, that's a 5-6, or that's a 7-8, or that's a 9-10. It's a 5-point scale anyway. It's a 5-point scale anyway. And so I was like, okay.
Exactly. You waste tons of time. Is it a 7 or an 8? And so that's one way to simplify, is get the scale simplified, make sure it's clear. What is a 1, 2, 3, 4, 5 in terms of criteria, so you don't have to debate it a lot. The next point is, I like to look at things visually. I don't like to multiply them together. So if you have a severity on one axis and occurrence on another axis, for example, then you can see, okay, in the upper right-hand corner of that, that's pretty high. Yeah, that's high risk. And so that might be a red. And so you can do a red, yellow, green. But if you do that, that doesn't mean you don't address greens. You might have a low-hanging fruit that's green that you can do something about. So it's only a very high-level guidance. Here's the prioritization that we can think about, because we don't have the resources to do everything. And so I've migrated from RPN to more of a matrix, and that matrix can be either severity occurrence, or it can be severity occurrence detection, if you're using detection, and I do think there is such a thing as detection risk. And that becomes a three-dimensional. But the point is, the red, yellow, green, or that type of thing is high, medium, low. All that does is prioritize where you put your attention. Let's address this first, then this, then this. It doesn't mean you don't go deeper and deeper.
Well, one of the things it was in an FME I was facilitating, that one of the engineers said, if we fix this one, which was like number 30 on the list, it takes out 15 of these things. It's a design change that individually it's not going to make the list if we follow the strict coding, right? But look at this. If we change this design right here, it solves that one, that one, that one, and he just kept on going. I'm like, that's brilliant. So it's the matrix is one way to do it, but it's also as that team puts together the list of things that are failing and occurrences and so on, it also provides a little bit of thought into, well, what are related here? What are the synergies here? What are part of it is low hanging fruit. What can we do to build momentum and fix immediately that doesn't cost us anything, and just do it? And there's others that have a ripple effect. And I thought those just a multiplier. So I always talk about that part afterwards. And then so I have three criteria. One is the high severity stuff we have to deal with, independent of all kinds of other things. We need to deal with that in some form or fashion. And we're going to come back to those. And then it's low hanging fruit. It's free and easy that, it's your design, Bill, and you're working on it. Can you make that an 1/8 inch, thicker or whatever? Well, yeah, no problem. No big deal. And eliminates that issue completely. And then there's others that have that ripple effect. And that takes really understanding what's on the list, what the team came up with. And I don't think I've ever seen it where it was obvious going into the FMEA, because we ended up with a list, I don't know, 20, 100 things on it. And over again, somebody says, these are related. And it's because of their perspective view of the design, but then not being aware that there were 20 unwanted outcomes that could happen for it. Oh, okay, let's fix that, And so I found a lot of benefit in, I don't think I've ever just ran out the numbers and said the list and here's the top 10, just do that. It just never made sense to me.
Well, that you're using thinking,
Oh, sorry.
which is so important.
I hate it when that happens. Sorry about that.
There you go again, Fred. It is really important to do that kind of thought. And we're talking about reducing risk.
Yeah.
That's what an FMEA is trying to do. It's trying to reduce risk. It's not trying to fill out a form. It's not trying to create a bunch of numbers. It's reducing risk. And really, it isn't done until risk is reduced to a level, I call it an acceptable level of risk.
Mm-hmm.
It's not zero. It means that the FMEA team thinks now you've got acceptable risk, and you want your management to concur. You want, if it's an important product, which it should be if you're doing an FMEA, then you want your management to concur that risk is acceptable. And so the risk prioritization that this person's writing about to me needs to be in the context of a simple way to get the risk visual and identified and addressed so you can get risk reduced to a level that's acceptable. That might be that lower priority issue you talked about that actually impacts 16 different things. That could pull the rug out from a lot of risk. So that's, and then the other thing I want to mention is, let's go back to high severity. And you say, okay, put a place marker on it. That's good. So I just have a couple comments on high severity that I will communicate to this person as well, that I'm answering. And that's that some people think you can't reduce severity. Severity is what it is. And I'm a huge advocate that you can reduce severity by design change.
Yep.
You can design like what's called fault tolerance or
fail safe.
Fail safe. Yep. And different techniques. And so the team should, when they have high severity, first try to reduce the severity. What can we do to the design or the manufacturing process so that nobody gets hurt, so that you still accomplish your overall mission, even with reduced time or takes longer or whatever, graceful degradation, things like that. So you can reduce severity and you should try. If you can't, there are some times when you can't, then you want to get occurrence and detection very, very low. Yeah. So I just want to throw that comment.
Well, I had a client years and years ago that made systems that monitored like a chemical processing plant. And usually they got called into the ones that, if that boiler explodes, now we've got this really bad poisonous gas floating all over town. It was kind of facilities like that, that if something goes wrong, it's going to be really bad. It's going to ruin a bunch of assets and it's going to kill people, kinds of thing, because their system was very expensive. And when I first ran into it, it was getting up to speed. And what they did is they had sensors all over the place, and then they had algorithms to monitor the processing, temperature, pressure, stuff like that. And if it was indicating it was going critical, it was getting to the red line on what this vessel could contain or hold, uh, it would then take steps to shut down the process or shut down to the system. And in some cases, shutting it down was also very expensive. This
Oh my gosh, yes.
material would solidify, or it would be unusable, and it's very expensive and everything else. But it was a trade-off. Do we want the $20 million problem or the $500,000 problem, and be safe? And so they
Yeah.
were riding this dangerous edge of, we don't want false failures where we shut you down just because it might be a problem, and we don't want to miss one either. So they had a really tough challenge in these facilities. But walking through a factory once, it was a polymer plant, and they had this, it looked like a bunker. It had like 18-foot thick walls and all the other stuff, and this big pressure vessel in the middle of it. And I said, what in the world's in there? And it's, is that where you keep your gold? And goes, no, we keep the explosion inside. What? It's like, does it explode much? And he goes, no, we spend a whole lot of time making sure the process is safe and in control and processing completely capably. And they spent a whole lot of time, like you said, reduce the occurrence, is process control, stability, do the due diligence on the research side and stuff like that. And they said, yeah, we do know that if something goes wrong, it's going to be a big bang, and we want to contain it. And so it was not just detection, which is what impression I got from this sensor system that I worked with, is detection and then react to it. It was coupled with a lot of coaching to those teams to make sure their process was consistent and they knew what they're doing. And this mixture and mixture rate and temperatures and everything else would have a much higher probability of leading to a good outcome. So they worked on both occurrence and the detection piece to really mitigate really bad severity problems. But yeah, I agree with you. There are ways to do it. It's really expensive when it's really a dangerous severity. Yet that's part of the game. That's part of what we do.
It's a trade-off analysis, and that's why I want to have management involved on high-risk issues where you have high severity. You want them to be involved because you have to make decisions about resources and scarcity and money. I'll mention one other thing, Fred, which is, and we're both strong backgrounds in reliability. And when I talk to FMEA teams, I say, okay, at least learn what a fault tree analysis is, if you're not learning all about reliability, because there are times when you have multiple tandem events, multiple faults, multiple failure modes that occur in tandem. They are best modeled with fault tree. If you have a high safety risk and you have an unwanted event, FMEA does not tell you the likelihood of the unwanted event. It just doesn't do it. You can put the effect in an effect column, but occurrences, people make this mistake, but the occurrence is not the occurrence of the unwanted event. It's the occurrence of the failure mode due to a cause. And sometimes you need to recommend and get done a fault tree so you can provide input to the trade-off analysis. What's the likelihood that someone's going to get hurt? What's the likelihood of an accident? What's the likelihood that this medical treatment will result in patient harm? Those are hazard analysis and fault tree analysis are other tools that can help you get to that and can supplement FMEA. So I think severity, like you said, flag it, and then let's go to work on it to see if we can reduce it and get occurrence and detection low, but also consider other tools to supplement.
Yeah, years ago, Mike Silverman wrote a book, and it was centered on halt. It was like every action we did centered on halt. It was, getting the design and prototypes and then do halt and then doing updates and fixes, and then halt findings would feed into FMEAs, would feed into accelerated testing, it'd feed in. And I thought, Mike, you could do this with FMEA. You could do this with all kinds of different things we do, is they're all interconnected. They're in what you're illustrating is, the FMEA is not a standalone tool. We may need the fault tree analysis. We may need accelerated testing to really find out, is this stress really going to be a problem or not? On and on and on. There's a lot of methods out there, and they all interact and interchange with each other. That, I think, is what the power is. It's not just one tool and you're done.
Absolutely. And you can use the recommendations column in an FMEA to launch a fault tree analysis or launch hazard analysis or any other tool. So it can come, if you're in an FMEA and someone says, we ought to be doing a, root cause analysis or something. Well, you can recommend that in the FMEA.
Yeah.
And then it's on record that you're
And then
going
it
to do
also
that.
gets into the priority. What are we going to do? Once we know what it needs to be done, it's then which ones are we actually going to do? And it goes on from there. Now it's FMEAs are fun. And every team's
They're
different.
fun.
Every team's different.
Isn't it interesting?
Yeah, one quick story for you, Carl. How would you handle this one? So it was a socket, a complicated socket for a very high pin count ASIC. So a computer chip thing that was probably 3 inches on a side square, and I don't know, thousands of pins that went into a socket. And the socket had to make good contact with all of those pins. And the socket was on another system that connected to the board, right? So there was the circuit board and the pads that were there, and then there was a connection to it. Then that connection went to another board, essentially another contact layer. And then above that contact layer was they called it it was like a piece of wire that was all twisted up together and kind of acted like a spring. And that had 2 ends to it. And then there was inside the chip body itself, there was the lead and its 2 ends to it. And then there was routing, and then it was a connection to the silicon. And then inside the silicon, there could be things that could be wrong. Right?
So I'll just make a comment on that, Fred, because I think I know where you're going with it. What do you do from an FMEA standpoint? Would that be the question?
Yeah. And so
okay,
we got to the point where it could be an open or a short, or it could be working, on any of the thousands of pins. And some pins mattered more than others. There were redundant power and redundant ground and stuff like that. But it was very obvious very quickly. We didn't know which one was what in that stack was causing the problem, or how likely it was going to be this fuzz thing connector versus this solder joint versus this versus that. And so we very quickly just abandoned the FMEA and said, all right, we need to figure out a way to figure out where the problem is. And so a couple of really smart failure analysts, went out and engineered a bunch of systems that did have faults in it. And then they potted it all and cut it all open and polished it all up, and were able to find the problems. And so we were able to then run some tests and evaluations and assembled some of them, and then cut them up to figure out where exactly was the most likely place that we had problems. It took months and months and months.
Let's flag this for a future podcast. I'll make a comment on it because it's a really good scenario. It's almost like a case study. Let's flag it for a future podcast but I'll comment this. I always like to start with a system FMEA that doesn't go down into the bowels of the hierarchy. So, because you're talking about a system, but that system has interfaces, it has lots of subsystems and components. It has electronics, it's got mechanical, and it has software. And it's a complex system. And a system FMEA, when you get to the cause level, it's not a root cause at the high level, but it can point, because if that cause of the system is high risk, then you can launch with recommendations a deeper dive on FMEA in that area. So that's one way. And another way is FMEA block diagram, which will show the interfaces. Because I think a lot of the issues that on that type of complex system are going to occur at the interfaces.
Yeah.
And that can be made visual with a block diagram. But I'd love to flag that and go deeper on a future podcast.
No, there's way more to talk to it.
Yeah, it's a terrific case study. Just rounding this off, Fred, the listener asked the question about risk prioritization, and which I appreciate that. If anybody that's listening here has any comments or thoughts about FMEA and risk prioritization, how you keep it from getting too big of an analysis that misses the vital few for the trivial many, anything that we've talked about here, we'd love to hear from you.
Yep. And you can do that over at accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. Carl and I and the other hosts are available through LinkedIn and our About pages. We look forward to your comments and questions. That sounded kind of flat. We really look forward to your comments and questions.
Like a disclaimer.
That's right. Yeah. And not for the fine
we do
print.
look forward to them.
We do.
Yes. That sounded like an AI bot.
Yeah, no, let's not go there. All right. Thanks, Carl. We'll see what comes in.
Thanks, Fred.
Cheers.
We'll see.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.